And tomorrow we're going to take a look at the applications that we did by hand and do those with the matrix. So we'll kind of wrap this part up. If a matrix is equal, like I think we did this one in class, a one-for-one correspondence. So the x is the same as the 5, the y is the same as the -8. So is everybody okay with finding the equations over there? Stop me if you're not. You need to be checking to see if you had any questions. Okay?
Wait, I do have a question.
Question.
Do we have to write it like that?
If you got it, you have to show me some kind of work. So
No, I mean, do we have to put it like...
no, like this, no, absolutely not. No, just leave your x, y, and z. This one, I didn't have the directions out there for some odd reason, so I just told you to add this one, right?
Yeah.
So everybody can add for 1 to 1 like this, 1 on 1. You didn't have to do the rest of these. You were fortunate because I left out the directions somehow. I don't know how they got left out. This one, I had you to subtract.
No,
Add this again. Everybody okay with the add?
yeah.
And you can put them in your calculator. Everybody comfortable putting these in the calculator?
Yeah.
But the matrix is nice, right? It's easy. It's just annoying because you have to put it in, then you have to quit, then you have to go back. You have to keep kind of going back and forth.
You told us to subtract for this one.
Subtract. So this one we subtracted. Did everybody get this?
Yeah.
Good. Now, the only bad part about a matrix is this. Should you put this in your matrix and you write your subtract out and you give me your matrix and it's not the same, does it mean that, what did you put in wrong? Like, did you put it possibly in wrong? Because you no longer have it there. You probably wrote over it. So it's very hard to tell. So again, my advice is once you put a matrix in, just print out the matrix so you can see it. Be sure that it's what you think it is. Because once you do it, and if the answer doesn't come out the same, we don't remember what we put in. It could be something weird went in there. What did I have you do to this? Add. So we said this is impossible, right? It doesn't match. It has to match exactly. So this is not possible. And we say undefined. This one was self-explanatory. Solve for x. This one is already solved for x, so you're going to multiply this guy by 3. Once you put your matrix in, you can do just that. Just put this in as a statement. It'll take your matrix A, multiply it by a scalar number 3. It'll take your matrix B, multiply it by a scalar 2. And then it will take those and subtract them. You can do them too. You can multiply this times 3, -6. This times 2, 0, and subtract -6 minus 0, and get -6. You can do it that way too. Since we're trying to figure out how matrices work, I like you to do them on the calculator too. This one you're going to solve for x. Again, then you're going to put that right like that in your calculator too. You're going to put matrix B minus 3 times matrix A. Okay? Everybody's good? No questions? Good. These are nice. To multiply this, remember your dimensions, the 2 in the inside have to be the same. So we have a 3 by 2 and a 3 by 3, and so therefore it's undefined. It was not possible. So we say undefined or not possible. Now, I'm just bringing you up on this because this is a perfect example. If we perhaps put the matrix definition backwards, and you did a 2 by 3, you know how I said you'll always see it when you put it in? So when Gabe did this, he did a 2 by 3, he did a 3 by 3, he said, yeah, it's possible, but he noticed as soon as he did this, it's not possible. So keep looking at it until you say, well, what did I do wrong? So therefore, it's just your dimensions were backwards, but you knew it wasn't possible to do as soon as you went to do it, right? So you said undefined. Undefined, impossible. The multiplication is the only one that I need you to multiply out. So Nick, what we do is we take their dimensions, rows by column. and the 2 on the inside have to match. The resulting matrix is what's left. We take the first row times the matching the corresponding elements of the second row. So -1 times 2, 6 times 0. We take a break. We do the next row, the next column, sorry. -1 times 3, 6 times 9. Now, we come to the next row, we come to the next line. You do this, this, this. I write them all out because you can see a pattern in this. Right away, just by eyeballing this, you can tell if you did it wrong. If these don't match up, there's this column, there's this column, this column, this column. Here's your rows. Here's your pieces in here, all 2s, all 0s, all 3s, all 9s. Then because we're at 3 by 2, then these 2, we're going to just put in our calculator, add them together, that gets this one. Add these together, that gets this one. Okay? So, multiplying is the one that I need you to do by hand. Can you check it in your calculator? Absolutely, you can check. Absolutely. That's probably the other ones we put in the calculators, we added and subtracted. But these guys we had to multiply by hand. I usually write them out so that you could spot if that's something wrong. All right, again, this one was a little involved. It was a 3 by 3 and a 3 by 3. So it was a little bit more involved than the other ones.
Should I put 3.5 or does it have to be?
You can put 3.5. I generally say switch them to fractions just because they take less space and you can see them better in the calculator, but that's the only one that was there. The nice part about these guys is it had a lot of zeros. So when you multiply anything by 0, it's 0.
Just one day is enough.
Yeah. I'm have to give you a test. I don't think I have a test. Hang on, please. Okay, take this one.
Where else do you think that's true?
Okay, so we're good? And was that the last one? No. Okay, we have a 2 by 1 and a 1 by 4, and it results in a 2 by 4. Again, multiply the 5 by that whole row. Multiply the 6, well, 5 by 3, sorry, 5 by 3, 5 by -1. You just got to keep track of them as you go. Then 6, and combine. Good? I think that was that the last one?
Yeah.
Yes. So, A, B, and C are our matrices. And the little c is a scalar. So, the associative property of matrix multiplication says I can multiply matrix A times matrix B times matrix C. And associative says change your parentheses. Okay, so I have an associative property for multiplication. Yes. Now, my problem is we do not have a commutative, no commutative property. Unless it's an inverse. They're inverse of each other. But we're not going to be seeing that yet. We won't possibly see that until probably like Monday. when they're inverses. But you can't swap them around. The reason being, if I have a 2 by 3, and I'm multiplying by a 3 by 3, this is why they're not commutative. If I switch them around to a 3 by 3 times a 2 by 3, these guys don't match anymore. So if this is matrix A and this is matrix B, I can't do this. I can't multiply them backwards because this won't match up most of the time. So we have no commutative property for multiplication unless it's true and they're inverses of each other. Okay, but we do have associative property of multiplication. And we do have a distributive property for multiplication. And your distributive property says if you're going to distribute over addition, then I can do CA plus CB. Remember, these are letters that represent a matrix. And my scalar property means that I can also switch them around. Scalar is by a number. So in the directions it said let little c be the number. So if I took little c and I multiplied A times B, it is the same as saying little c times A times B. Like if I say this. Right, it doesn't matter what order I'm going to multiply those in, because it's just as long as one of them gets multiplied by 3. Again, we have no commutative property for that.
Alright, let's try the first one.
Hang on. We're not finished here. All right, now. Whoa. So, when you work with this, where's the equations on this? Did I pass it? No. Okay, so when you work with this, this is a subscript. Let me explain subscripting first. Do you know what a subscript is?
Isn't it a number, like, underneath, like, you know how it says X and then the 1 right there, isn't that?
This means like the first element of X.
Yeah.
This is like the first element of X. This is the second element of X. And this is the third element of X. Normally what happens is this. Normally when you get your answer, we say X, Y, and Z. But we don't have to call them X, Y, and Z. We could subscript through them and call them X1, and then Y would be X2, and Z would be X3. The reason we like to go over this is a lot of college books, instead of using X, Y, and Z, will subscript X1, X2, X3. So just tell me what your values of X, Y, and Z are, and we'll call them X1, X2, X3. Basically, that's what this means. To solve the equations, a lot of times you'll see this. They'll separate this out and multiply them this way. This is the coefficient of the equations. This is the constant of the equations. And this is what the answer is. So if you take your answer and you multiply it by your A, you should return back to B, the constants. Okay, just another way to look at it. Will we do a lot with that part? No, but just so that we make you aware of that you'll be seeing these things. And we'll do a couple of things for this. Because a lot of times, this is the format that you see this in. And instead of them doing it this way, sometimes they go like this. X1, X2, X3. They subscript rather than put X, Y, Z. Subscripting is not the same as squaring a number, it's just listing an element. Like I can't call them all X because they're all different. So I call them X1 is when you have a set of numbers. So you call your set element 1, element 2, element 3. You just subscript through them. So we're going to take out our coefficients. We're going to take out our constant. This is called the constant part. Okay? Now, if we turn around and we put this in your RREF. I think it's too big here, that's the problem. I'm not getting everything that I wanted here. There. If we do an RREF on this, pull this matrix out. Do RREF. Put it in your calculator and do RREF on it. And let's work our way backwards through the solution.
Look at our EF to give you the answers.
RREF is going to give us the answers.
Oh.
REF is going to make us work it backwards. But it's just so much easier to do REF. It's still in the matrix with the on and off things in it, but we'll just take them out. You'll still get this. 1, 0, 0, your answer. You'll still get this. This is what we're going to take out and call x equal. Just another way you might see this. And it kind of shows you all the different things you can do with the matrix. So what'd you get for answers?
1.
1.
Negative 1. 2.
So if this is my x, and this is subscript 1, subscript 2, subscript 3, all we need to do is just set this equal to this column. 1, negative 1, 2. Now, if I take this x and I multiply it by this one, I should get b. Just another way to play with the matrix. You're going to have to separate these two and two separate matrices. Multiply, make a matrix for this, multiply this one times this, and your result will be that one. Just another way to look at it. Change their mind. Okay? I'm not too hung up on that, as long as you just are aware that they do this. Now, here's some of the dimensions. Let's see if these are possible to do. Again, we want to follow order of operations. So, first thing in number 1, what do we have to do first? 3c. So we can multiply a scalar times anything, right? So this part will always work. How about b minus c? Will it work? When you subtract or you add two matrices, don't they have to be the exact same dimensions?
Oh, no.
So is b and c the exact same dimensions? Nope, not possible. Undefined. Undefined, not possible, doesn't work. And always be careful when you subtract, because you want to go from b to c, if in fact it was able to work. So b times c. b is a 2 by 3,
So it's possible.
and c is a 3 by 2. Good, so it's possible. And what will their result be? 2 by 2. Good. c, I'm going to have to move this down. So what am I going to do first in number 3?
C times B.
C times b. So, c is a 3 by 2, and b is a 2 by 3. Is that possible?
Yes.
What will my result be?
3.
3 by 3, and I want a minus from d, and d is a what? Is that possible?
No.
No, not possible. Undefined. Okay, what do I want to do in number 4? b times c. So 2 times 3 times 3 times 2. Is that possible?
Yeah.
Okay. And what is D?
2 times
2 by 2. So what is my result?
2.
2 by 2.
2 by 2. So let's see if this associative property works. Associative says keep them in the same order, change the parentheses. So now I'm going to do C times D. So C is a 3 by 2, and D is a 2 by 2. Good so far? What do they result in?
3 by 2.
3 by 2. And what is B?
2 by 2.
2 by 3. And isn't this the same?
Yeah.
So doesn't this prove the associative property?
Yeah.
Good. Okay. So that proves our associative property. So let's look at, what do we do first here in number 5?
CC.
B times C. So B is a 2 by 3, and C is a 3 by 2. Is that possible?
Yeah.
And what am I going to be resulting in?
2 by 2.
And I have to subtract D, which is a 2 by 2. Is that good?
Yeah.
So what result will I get?
2 by 2.
2 by 2. And I have to multiply this by A, which is a 2 by 3. Is that possible?
Yeah.
And what's my result?
2 by 3.
2 by 3. Good? Okay? So just kind of get used to playing with your